In this video, we are going to look at elementary operations of a matrix. So the first thing is we'll quickly discuss what are the elementary operations on a matrix. The first operation is, like, you could go for a set of row-wise operations or column-wise operations, but when we are doing the elementary operations on a matrix, we either stick onto row operations or onto column operations. So I'm going to write row operations as well as column operations side by side, but you need to remember that when you actually apply the operations, you need to stick onto one of them. If you start with elementary row operations, you need to continue applying the row operations throughout. So the first rule here is Ri, this double-headed arrow, we will read it as Ri interchange with Rj. Ri means maybe the first row, the second row, the third row. So the first row interchange with third row, R1 interchange with R3, or you could say R2 interchange with R3, or R1 interchange with R2. So it's interchanging of two rows. But it's also possible to do the same operation on columns. You could interchange two columns. So all the operations which we are discussing here are also applicable to columns. This is the second property or second operation possible. Ri changes to k times Ri. Ri changes to k times Ri, which means any row can be multiplied by a number. So if you can multiply by a number, you could also divide by a number, of course non-zero. So I could say something like R1 changes to 2 times R1. I could multiply. Or I could say R3 changes to R3 divided by 7. I could multiply by a non-zero number or divide by a non-zero number. Any row can be multiplied by a non-zero number. Of course, the same thing is applicable to columns as well. I could say C2 changes to 3 times C2. Second column becomes 2 times the second column. The next operation is, we say Ri becomes or changes to Ri plus a multiple of another row. So what it actually means is that I could say something like R1 changes to R1 plus 2 times R3. To the first row, a multiple of another row can be added. So this actually you will understand it when you start doing the questions. To any row, a multiple of another row can be added. Of course, also can be subtracted. So that's the operation, but of course it is available on columns as well. To any column, you can add a multiple of another column. Add or subtract a multiple of another column. So we're going to do some application questions of it. The question here says, using elementary operations, find the inverse of the given matrix. Use this elementary operations. Using elementary operations, find the inverse of the given matrices. Now sometimes they will specifically tell what kind of an elementary operation is what they are looking for. They could probably specify it like using elementary row operations, find the inverse of the given matrix, or they could say using elementary column operations, find the inverse of the given matrix. If nothing is mentioned, like in this case, using elementary operations, I prefer doing elementary operations on rows. Okay, so I'm going to do by elementary row operations. If I have to do it on columns, it is the same thing. You just follow these rules. Yeah. So we are going to actually focus only on elementary row operations. Let's look at the first question. So the question is here, there is a matrix given to me. So this matrix is what is given to me, and I need to find the inverse of this matrix using elementary row operations. So let's start doing the question. So to start with, we write a matrix equation. And the matrix equation we form with the given matrix A is the given matrix A. Any matrix A can be written as I into A. Any matrix A can be written as I into A. I is the identity matrix, so identity matrix into any matrix should give me the same matrix. So I can say A is equal to I into A. So that format you need to remember, that's how you write it. We don't write it as AI, we write it as I into A. We keep AI if you have to do column operations. So we are trying to do only row operations. So we write A is equal to I into A. So remember that format. And then what we will do is, on the left hand side, what is A, I will copy. On the right hand side, what is I, the identity matrix. Of course, identity matrix has to be of order 3 by 3 because A is of 3 by 3. So I'll write the identity matrix, and the second A I won't replace by its value. I will keep it as A itself. So how would it look like? On the left side, I'm copying my A matrix. On the right side, I need to write my identity matrix of order 3, which is 1 0 0 0 1 0 0 0 1 into the right hand side A matrix. I'm keeping it as A itself. I don't replace it by its value. Now I'm just going to copy this question one more time here. So I have A matrix written as it is. I copied the A matrix. Then I have the identity matrix and then followed by A. So A is equal to I into A. Only thing is I replaced A by its value. So A is equal to I into A. Now what we are planning to do is, we learn this transformation of matrices. We know how to transform a matrix using the 3 operations which we discussed earlier. So what we will do is, we will somehow try and make this matrix, transform it into an identity matrix. But the thing is, if I make some changes on the left hand side matrix, I need to make the corresponding change on the right hand side matrix. So whatever changes I do on the left side, the same thing I do on the right side. So obviously this is not going to be anymore identity matrix. It will change. And finally, when I change this into an identity matrix, I'll say I is equal to some matrix B into A. And if B into A is I, because I'm making my left hand side into an identity matrix, if B into A is I, since the answer is I, one of the matrices should be the inverse of the other. So that means B has to be the inverse of A. So B is A inverse. That's the logic we are going to apply. So what I want to do here is convert this matrix into an identity matrix. Now, how would I convert this into an identity matrix? Identity matrix looks like 1. Here it should be 1, 0, 0, 0, 1, 0, 0, 0, 1. That's what I want to do. But what we're going to do here is, I'll somehow try and make A11 into 1. And then use that, the general format I'm telling you. So A11 will be made into 1. Use that 1 to make the remaining elements in that column into zeros. Then you should make A22 into 1, make the element above that and below that into 0. Then you make A33 into 1, and all the elements above that should turn out to be 0, and then it will turn out to be identity matrix. But we follow that particular order one more time. I'll try to make A11 into 1 and make the remaining elements in that column into zeros. Then I'll make A22 into 1, make up and down 0. Then I make A33 into 1 and make the remaining elements, the above elements, into zeros. This is the format. So I want to have 1 here. And the easiest way of making A11, which is actually 2 there, into a 1 is divide the first row throughout by 2. That's the easiest way. So my operation here, the first transformation should be R1 changes to R1 divided by 2. That should be my first step. R1 changes to R1 divided by 2. But the thing is, if I follow that transformation, 2 of course changes to 1. But I get 3 by 2 minus 3 by 2, 3 by 2 and 1 by 2. So rest of the calculation for me is all going to get that fraction involved. So I don't want to directly involve a fraction right in the beginning itself. So I will do that when it is absolutely necessary. No harm in doing it. If you are comfortable with fractions, you could go ahead and do that. What I am trying to do is there any other way of getting one? Okay, I can visualize it this way. Suppose you interchange between R1 and R3. So 3 will go up there. Then I can do subtraction between R1 and one of the other two rows, and 3 minus 2 will become 1. So when I start writing, you will understand it better. So I'm going to say interchange R1 and R3. So I'm going to interchange R1 and R3. R1 will go to R3's place, and R3 will go to R1's place. So we are interchanging between R1 and R3, which means my R2 remains the same. So whichever row remains the same, copy that first. So I'm copying my R2 as it is. 2, 2, 3, 0, 1, 0. I copied it. Now I'm going to interchange R1 and R3. So I'll take my R3 from here and put it in the first row's position. Take R1 from there and put it in the third row's position. You are interchanging R1 and R3. See, I took my R3 from here and placed it in the first row's position. I'll take my R1 from there and place it in R3's position. So I interchange between R1 and R3. But still, what am I looking for? I'm trying to make my A11 into 1. I want to make this element into 1. In place of 3, it should be 1. So there are two ways of doing it. I could say from R1 subtract R2. So 3 minus 2 will be 1. Or I could say from R1 subtract R3. So which is better, you should see. I mean, there won't be so much of difference between the two. Like if I do R1 minus R2, 3 minus 2 is 1. Minus 2 minus 2, that makes it minus 4. And that's minus 1. But if I do R1 minus R3, maybe 3 minus 2 is 1. Minus 2 minus 3 is plus 1. So instead of the previous minus 4, I have 1. I think R1 minus R3 may be slightly better. So this is what I thought of first. R1 minus R2. But that's going to give me 3 minus 2, 1. Oh, of course, that's what I am looking for. But minus 2 is minus 4. No, I don't want that because I get a better operation here. R1 minus R3. What is R1 minus R3 going to be? 3 minus 2 is 1. Yes, that's what we are looking for. Minus 2 minus 3. Minus 2 plus 3 is going to be 1 there. I have a smaller number, and 2 minus 3 is minus 1. So I'm going to go ahead with this operation. R1 minus R3. Our aim is only to get A11 into 1. So let's see. So I'm copying this format, and I know the change is happening only to R1. So which means R2 and R3 should remain the same. So I'm copying. So whichever row is not under change, I should copy them first. So 2, 2, 3, 0, 1, 0 is the second row I copied. 2 minus 3, 3, 1, 0, 0, the third row I copied the same. Now I will do this subtraction, R1 minus R3. 3 minus 2, 1. Minus 2 minus 3. Minus 2 minus 3. Minus 2 plus 3 is 1. 2 minus 3 is minus 1. And on the right side, 0 minus 1 is minus 1. 0 minus 0 is 0. 1 minus 0 is 1. So now that I have A11 as 1, the next step is to make the remaining elements below that element into zeros, which means I want 0 here and I want a 0 here. That's for that I make use of my R1. From R2, if I subtract twice of the first row, because I want in place of 2, I want 0 to happen. So what I'll do is, I'll say R2, see I have written it here. R2 changes to R2 minus twice of R1. From the second row, if I subtract twice the first row, 2 minus 2 will be 0. So I just want 0 there. So in that case, can't I get one more 0 straight away here in the third row as well? What should be this corresponding operation? From R3 also, you subtract R1. So two operations at the same time. R2 changes to R2 minus twice of R1. From R3 also I should subtract, I said R1 previously by mistake. From R3 also I should subtract twice of R1 because 2 minus 2 will make it 0. So I'm making use of the same row R1 to change the other two. So some of you might think, why don't we do R2, R3 minus R2? You could, but then I can do only one operation there. So R2 minus R3 or R3 minus R2, only one of them. I can't do both the ways because one row is going to be under change. So that's why what I'm doing is I'm keeping my R1 the same and changing the other two rows. Why? Because I want 0 here and 0 here, those marked elements. So what am I saying? R2 changes to R2 minus double of R1, and R3 also changes to R3 minus twice of R1. So I wrote that operation. So which means when I'm doing this operation, my R1 alone remains the same. So I copy R1 as it is. The rest I'm going to calculate. So I'm going to calculate each element. 2 minus twice of 1. 2 minus 2 is 0. 2 minus 2, 0 here again. 3 minus minus 2, double of minus 1. So that's going to be 5. So look at that again. Second row minus twice of the first row. 2 minus 2, 0. 2 minus double of 1. 2 minus 2 is 0 again. 3 minus minus 2. 3 plus 2 is 5. On the right side, 0 minus minus 2, which will be 2. 1 minus twice of 0. 1 minus 0 is 1. 0 minus twice of 1. 0 minus 2 is minus 2. So I get 2, 1, minus 2 there. And I do the same thing with R3. So how do I do that? 2 minus twice of 1. 2 minus 2 is 0. Minus 3, minus 2. Minus 3, minus 2, minus 5. 3 minus minus 2. 3 plus 2 is 5. On the right side, 1 minus minus 2. 1 plus 2 is 3. 0 minus 0 is 0. 0 minus 2 is minus 2. So I settled the first column now. I made A11 into 1 and made the remaining elements into 0. I know what is to be done next. Make A22 into 1. Make up and down zeros. Then make A33 into 1 and make the remaining elements into zeros. I'm going to copy this step one more time here. So that's the step we just finished. I'm just copying that as it is. And now I'm going to make my A22 into 1. But unfortunately, this is 0. And if I want to make it into 1, the only way is to add 1 there. So you can think of something like R2 changes to R2 plus R1. So that will become 1. But I won't do that because when I try to make this 1 by adding R1 to the second row, this will become 1. But this 0 will also become 1. We made that 0 with great difficulty and we don't want to lose that 0. So we won't try to lose, or we can't afford to lose any of the zeros we already made. We just want this element to become 1. So I really can't get 1 there. So what I'm thinking is, why not interchange R2 and R3 first? And what's the logic there? We'll see. Let's first interchange R2 and R3. Because I couldn't make 0 into 1, so I'm going to interchange those two rows, R2 and R3. So R1 is copied the same, it stays the same. And I'm interchanging R2 and R3. So R3 I pick up and write it in R2's place. 0 minus 5, 5. 3, 0 minus 2 is going to be in the second row's position. And now the second row will go to the third row's position. So that means 0, 0, 5, 2, 1 minus 2 will go to the third row's position. I still haven't got that element as 1. I want to get that as 1. How would I make minus 5 as 1? The only way to make it 1 is to divide throughout by minus 5. So my operation for that would be, I want 1 there, so I will say R2 changes to R2 divided by negative 5. So I'm going to copy this step again. So when I copy, R1 will remain the same, R3 will remain the same. Change is only happening to the second row because you are dividing that row by -5. So I will copy first row as it is, the third row as it is, and the change is happening to the middle row. Each element will be divided by -5. So 0 by -5 is 0, -5 by -5 is 1, 5 divided by -5 is -1. And on the right side, 3 divided by -5 is -3 by 5, 0 by -5 is 0, and -2 divided by -5 is 2 by 5. So that's what I have. So I have made A22 into 1. Now what I need is, if once A22 is made 1, up and down should become 0. Above that and below that should be 0. Below that is already 0, so I just want the element above that to be 0. That's pretty easy. I could say R1 changes to R1 minus R2. From the first row, you subtract the second row because 1 minus 1 will make it 0. So let's do that. The change is happening only to the first row, which means second row and the third row I will copy. So I'll copy the second row as it is, and the third row 0, 0, 5, 2, 1 minus 2 as it is. So I copied my R2 and R3 the same because the change is happening only to R1. We said R1 changes to R1 minus R2. So we're going to do that R1 minus R2 subtraction. So how would you do that? R1 minus R2. 1 minus 0 is 1. 1 minus 1 is 0. Minus 1 minus minus 1 is 0 there. Here, this is fraction subtraction. Minus 1 minus minus 3 by 5. I don't want to do that in my head and get it wrong. So I'm going to do it on the side. So let's see. Minus 1 minus minus 3 by 5. Minus 1 minus minus 3 by 5. And I take LCM. When I take LCM, it's minus 5 plus 3. And minus 5 plus 3 is negative 2 by 5. So I wrote negative 2 by 5 here. The next element is 0 minus 0, which is 0. And the last one is 1 minus 2 by 5. R1 minus R2 is what I am doing. So 1 minus 2 by 5, which is 5 minus 2 by 5, which is 3 by 5 here. So I have got A111, the remaining elements 0. A221, the remaining elements up and down 0. Now what I need is A33 to be 1. I want to make this into 1. And for A33, you don't have to even analyze that situation for a minute also, because it only works in one way. Whatever number comes there, divide throughout by that number. So I'm going to say R3 divided by 5, which will get me 1 there. So your next operation, I'm just copying the previous step, okay, just for me to see it and do the next step operation. So this is what I want. I want 1 there, and what I have figured out is R3 should be divided by 5 to get A33 as 1. So which means you will copy your R1 the same, you will copy your R2 the same. But in R3, I am dividing each element by 5. So 0, 0, 5 by 5 is 1. And then 2 by 5, this will become 2 by 5, 1 by 5 and minus 2 by 5. 2 by 5, 1 by 5, minus 2 by 5 into, outside I still have that A. Now what do I need? If once I make A33 as 1, all the remaining elements in that column should be 0. I already have 1 0 up there. I just want this element to be 0. That's pretty easy again. To the second row, because minus 1 plus 1 will make it 0. So to the second row, you should add the third row. R2 changes to R2 plus R3. To the second row, add the third row. R2 changes to R2 plus R3. So we're going to do that. So R2 changes to R2 plus R3 means only the second row is changing, which means the first row and the third row I will copy the same. See, I copied the first row as it is, I copied the third row as it is. But I'm going to work on the middle row. Second row changes to second row plus the third row. R2 changes to R2 plus R3. To the second row, we are adding the third row. So what do I get? 0 plus 0 is 0, 0 plus 1 is 1, and minus 1 plus 1 is 0. So I get 0, 1, 0. On the right side, minus 3 by 5 plus 2 by 5, which will be minus 1 by 5. 0 plus 1 by 5, which is 1 by 5. And 2 by 5 plus minus 2 by 5 is 0. So at this stage, what I am seeing is that I can see I on the left side, and on the right side some matrix B into A. It's like this. I is equal to B into A. So this is the identity matrix. Identity matrix I is equal to some matrix B into A. If the product of two matrices is I, if B into A is I, then B is the inverse of A. That's why the product is I. So if B into A, since B into A is I, B has to be the inverse of A. So I will say therefore B is my A inverse. So this has to be the inverse of A. So since this is the inverse of A, that's why the product became I. So I'm going to say this is nothing but A inverse. So therefore A inverse is equal to the 3 by 3 matrix which I have here. So I found A inverse. So you need to redo this question, not just once, more than once, 2 or 3 times. You should redo it and check the answer. You could go ahead and try your own steps, but for the first time when you do, probably you should follow the same steps everywhere and make sure that you get this answer. The operations could be different, but make sure that you reach here. Now, how would you ever verify that your answer is correct? So since you have an A inverse here, if you multiply A and A inverse, A into A inverse should always be I. So you just multiply your given matrix A with this A inverse and see if the product is 1, 0, 0, 0, 1, 0, 0, 0, 1. If you are able to get it that way, this is correct answer. I'm not keeping any homework on this video. It took so much of time to finish one question. You need to redo it, practice it. I'll include homework in the next video.